Hey guys, hope you're doing well today, and it's another great day to do some math. Today we'll be solving equations with combining like terms. And in case you don't remember what like terms are, well, we got some definitions for you there. But basically, when you're solving equations with combining like terms, you are combining like terms first on the same side of the equal sign, and then doing a two-step or one-step equation. So let's quickly review what terms are. Okay. A term is a number or a product of a number and variables. So down here, how many terms do you think you see? There are 4 terms, okay? They are separated by addition or subtraction. A constant is the one that doesn't have a variable. Like terms have the same variables. They have identical variables. So if we're going to combine like terms, you can only combine the 7a and 4a and make it 11a. And the numbers in front of the terms are called coefficients. All right. So let's look at a couple examples of solving equations with combining like terms. All right, so first we're going to take a look at a couple ones dealing with fractions here. All right. So when you have fractions and when you have to combine them, okay, we're going to be combining them by adding or subtracting. So you need a common denominator. So the common denominator of 4 and 5 is 20. So I multiplied the top equation by the first fraction by 5 and the second fraction by 4. Okay, and then we rewrote our fractions like this, okay? So now that we have them rewritten with the same denominator, we can combine them. And when you combine like terms, you are going to be adding the fractions here because they're both negative, okay? And you want to think about this as being negative 5 minus 8. Negative 5 minus 8 is negative 13. Okay, you keep the denominator the same, which is 20. Okay, so we have negative 13, 20 of d equals 39. The next thing you guys have to remember how to do is how to get rid of a fraction that's multiplied by a variable. And this was similar to your inequality test that you guys just took. All right, to remove a fraction that's multiplied by a variable, you want to multiply by the reciprocal. Okay, and to cancel out the negative, you need to multiply by another negatives because 2 negatives equal a positive. These 2 negatives would cancel and equal a positive. All right, so you also multiply this other side by the same fraction. Okay, so negative 20 over 13 is the reciprocal. Okay, you could reduce. Okay, you could reduce this, make 13 into a 1 and the 39 into a 3. And so you would end up with negative 60. Okay, negative 20 times 3 is negative 60. All right. Now, if they are decimals, you do the same thing. You want to combine like terms first, and these are both d's. Now, notice it does have minus and negative, so in that case, you want to rewrite minus and negative as a positive. And then you have a negative plus a positive, and when you have a negative plus a positive, the signs are different. So you want to subtract. Okay, so you have 3.05d equals 8.54. Then you just solve this simple one step by dividing both sides. All right. So before we do any other ones, let's look at a couple ones on Pearson. And you guys could probably find a section in your book and look at these too. It is section 7.1. I'm not sure of the page though. Anyhow, on this one, you are combining like terms first again. They are both negative terms. They both have a y in it. So when they are both negative, they both have a y, you need to add the numbers, keep the sign the same. So it's going to become a negative 9.7y. Then once again, you need to cancel this one step, cancel the multiplication with division, cancel a negative by dividing by a negative. And then on the other side, you have a negative divided by a negative, which is equal to a positive 9. All right, let's look at example dos here. 2 for those that don't speak Spanish. All right, Celine bought a computer screen on sale for 35% off the original price. What was the price of the computer screen before the sale? Okay, so we know the sale price is $130. It's 35% off the original price. So what I would do if I had a problem like this is I would first state the original price, since we're looking for that. Okay, we're going to call that our variable. All right, so they called it P. P is the price of the screen before the sale. All right, so let's consider they're going to do a little bar diagram here. So the original price is P. Okay, it is being taken off by 35%. Okay, so you're going to write 35% as a decimal, which is 0.35p. And anytime you have a percentage, you want to make it into a decimal. So just remember, you move the decimal point twice to do that. Okay. Okay, so now we're going to take P, which is the original price. We're subtracting the discount, 0.35p, and we're ending up with $130. So that's the idea for our equation here. Okay. So, as it's buffering our equation, there you see we have P, which is the original price, subtracting the discount, and that's equal to the amount of money here. Okay, so then combine like terms. Now, to combine like terms in this case, you have an understood 1 in front of P. Okay, so it's 1 minus 0.35, that's equal to 0.65p. Then it's a two-step, you divide by 0.65, and you get 200. So the original price was $200 for this computer. All right, let's take a look at this one right here. Nat's grocery store bill was $150, which included a 5% club discount. All right, so the bill included the discount. What was Nat's bill before the discount? Okay, so we'll say like D is before, and excuse my writing with this little marker here. That's really tough. Okay, before the discount. Okay, so D is before the discount. Now let's use a different letter because it doesn't make sense. All right, let's say B is equal to the bill before the discount. Let's be clear. Bill before the discount. All right, so you have the bill. The discount was 0.05B. Okay, so that's 5%. 5%. Move the decimal twice. Oops, nowhere to go, so let's add a 0 is 0.05b. Okay, 5% of the price. Okay, that's the discount, this little chunk right here. And it's equal to the new price, which is 150. All right, so if we're going to solve this one, we're going to take and combine like terms. Understood 1 here. Woo, got a little crazy there. All right, so this is equal to 0.95b. 1 minus 0.05 is 0.95b equals 150. All right, and then you just need to grab your calculator to save some time. 150 divided by 0.95. Boom. Okay, it's about $157.89. If I did that right. Okay, which I think I did. I should probably check. Anyhow, you just have to trust me that I did that right. So that would be his bill before the discount, which makes sense because it's more expensive than $150. All right, let's go back and look at example number 1. So back to the PowerPoint. All right, here's example 1, which you can actually read in the book too. Gina has 36 yards of fabric to make matching sets of placemats and napkins. Okay, so they have to come in pairs, placemat with napkin. It takes 1 1/3 yards to make a placemat, 1/6 yard to make a napkin. How many matching sets can she make? All right, so our variable is going to be how many matching sets. So you might want to use like M for matching sets. All right, so here's a little diagram here. So she has 36 yards total. Some of them go for the placemats. 1/3 X. X is the number of matching sets. And X over here is, once again, the number of matching sets. And it's 1/6 yard for the napkins. Okay? You're going to be doing what to get 36? Well, you're going to be combining them. So you're going to add the placemats and the napkins together. Okay, so here is your equation. You need to turn into a mixed number. We need to take this mixed number and turn it into an improper fraction before we go any further. So let's take the denominator, 3, multiply it by 1, add the top, so that's equal to 4/3 x plus 1/6. We need to have a common denominator, so we're going to make that into 6. Okay, so the first fraction, 4/3, we multiply the top and bottom by 2, and we get 8/6. Combine 8/6 and 1/6, we get 9/6. X equals 36. And then remember, to get rid of that fraction times the variable, we multiply by the reciprocal. Yeah, it says inverse there, but reciprocal is probably the proper terminology. Okay, so anyhow, you could cancel out everything on the left except for the variable. Here you can cancel out the 9 and 36. Okay, the 36 would become a 4, so you have 6 times 4, and that would mean you can make 24 matching sets. Pretty cool. Alright, well, I hope that was a good video for you guys. Let me look at one other problem real quick that I know that I want to go over with you, and it's on Pearson here. It's one of the try-its. It's example 1 try-it. Alright, so let's get to the try-it. There we go. So there's this one here is just kind of like the other one, but I want to look at the convince me problem here. All right, suppose the equation was this. Okay, can you combine the s term and 4.6? And the answer to that is, let's think about it. Nope, you can't combine those. Those aren't like terms, so you don't want to combine those two. But what you would do first on this one is you would combine the 9.99s and the 7.99s. Okay, you would add those two together, and then you would have to do a two-step equation from there, okay, to try to get s by itself. Okay, guys, hope you have a great day, and we'll talk to you later. Bye-bye.